Hello, everyone. Thanks for coming to my talk. And thank you, Asia Blockchain Summit, for inviting me. I'm particularly excited to be here today. So my talk is the state of Bitcoin and a future with Lightning. And I'll talk about where Bitcoin's at today and what the Lightning Network is and where we're going. So I'm the Chief Strategy Officer at Blockstream. Previously, I was the COO at BTC China, or BTCC. It's one of the largest exchanges in the world and mining pools. And before that, I was at Ubisoft. So Blockstream is a Bitcoin and blockchain infrastructure company. So in a nutshell, we work on a lot of things around Bitcoin. We try to augment Bitcoin, make it stronger, more robust, and more nuclear-proof. We are a venture-backed company. We've raised about 90 million over a seed round and a Series A round. And we're traditionally funded, so our backers include Reid Hoffman, Horizons Ventures from Hong Kong, and Digital Garage, a public Japanese company. Some of our flagship products include Liquid. It's an inter-exchange settlement network. So what it does is it lets you move funds very quickly between different crypto exchanges or trading desks or financial institutions. And this is a sidechain. So Blockstream was founded in 2014 to pioneer sidechain development and R&D. You can also issue assets in Liquid, which is really interesting. And we also have Blockstream Green, which is a non-custodial multi-sig wallet that lets you control spending, velocity limits, and such. It's also compatible with some of the more popular hardware wallets, so it's a really good solution if you're taking your Bitcoins out on the go. We have Elements as well, which is a blockchain platform. It's where we do most of our R&D. So things like SegWit, we first R&D'd them and put them into Elements. And confidential assets, confidential transactions, those all went to Elements first, and then we eventually released it in Liquid in a production environment. So Blockstream Satellite is probably one of our more interesting things out there. So this is a satellite service. So it's broadcasting the Bitcoin blockchain all around the world. We're using 4 geosynchronous satellites. They're about 30,000 kilometers out in orbit. And they're high-powered satellites. So what that lets us to do is broadcast to users on the ground with smaller home TV-sized dishes. So this helps add redundancy to the Bitcoin blockchain. So in the event of a network partition, you still don't have to have a network split as long as one person in a country is running this dish and getting blocks. And finally, we have the cryptocurrency data feed, which is a partnership with ICE. So ICE is the owner of the New York Stock Exchange and Bakkt. So what we're doing is we're collecting and scraping data from all the crypto exchanges and creating this crypto feed that is sold to institutional Wall Street investors. So we do a lot of open source contributions at Blockstream. We have one full-time developer working on Bitcoin, but a lot of our guys are also contributing in their free time working on Bitcoin. And we released Explora, which is a Bitcoin blockchain explorer, and also for Liquid. So people have taken this code and have set up their own block explorers. I think Bitcoin Magazine has one as well as Bull Bitcoin. We also invested in Lightning very early on. So since 2015, we've been working on Lightning R&D. We brought on Rusty Russell. He's a Linux kernel developer, and he kind of leads the project for us at Blockstream. We also have Simplicity, which is a smart contracting language. When it's ready, it'll go into Elements and then possibly Liquid, and maybe someday Bitcoin. So let's go quickly through this part. What is Bitcoin? I like to call it digital gold. It's the most secure cryptocurrency and blockchain platform out there, and it is the world's first reserve cryptocurrency. So typically when crypto goes, when Bitcoin goes up, crypto goes up, and if Bitcoin goes down, all crypto goes down with it. So it's really tightly bound to the whole ecosystem. Bitcoin is a decentralized peer-to-peer network of nodes and miners, so anyone can join the system and participate. And the nodes relay transactions and blocks. And there's a blockchain behind Bitcoin, and I just want to show you that blocks actually do need physical space. So transactions are taking up physical space in the blocks. And block space is limited so that we can keep the network decentralized and everyone can participate. Because there comes a point at which the blocks get so big that you can no longer run a node at home. But with Bitcoin, you can still run it on a Raspberry Pi or an old laptop. So blockchains are inefficient and can't scale unless they sacrifice decentralization. And we see this with a lot of projects out there, like competing chains or even Libra, which doesn't actually have a blockchain. Because if it is a blockchain and it's secured through proof of work, then it's very hard to scale this. Also, transaction fees are often a hot topic about Bitcoin. But I want to point out here that because they consume actual space in a block, you're competing for a scarce resource. And as the price of Bitcoin goes up, the transaction fee price will also go up as well. So you can see in this example, you're paying the same amount of Satoshis per virtual byte. When Bitcoin's $100, you're paying 22 cents. But when Bitcoin's $10,000, you're paying $2.20. So people that complain about fees are generally saying Bitcoin is too expensive. So as it becomes more valuable, fees become more expensive in fiat terms. It's important to remember that. So the state of Bitcoin right now, we are very geographically distributed. We're resistant to natural disasters, and no single government can control Bitcoin or do anything to Bitcoin. So I think in today's news, the US government sent a letter to Libra saying stop development. Well, you can't send a letter to Bitcoin saying stop development. This doesn't work. As I mentioned, we have lightweight nodes because we've done really smart scaling with Bitcoin. We've kept the blocks small, we've kept everything very efficient, so anybody can run a node and participate, and that keeps Bitcoin really decentralized and censorship resistant. And we also have ISP diversity, so there's not one single ISP. A country could potentially block a Bitcoin transaction, but because we have something like Blockstream Satellite, that's no longer really an issue because anybody can set up a dish for under $100 and get the Bitcoin blockchain. So another key aspect for the state of Bitcoin is we're reaching an all-time high. We've hit 60 exahash for Bitcoin hash rate, and we've also increased the block size. So right now, I think the network is very secure in terms of miners and hashing power. I'll just go quickly through this part. So we have a lot of on-chain technology improvements, including Taproot, Schnorr. These are just ways to scale up Bitcoin and make it more extendable. Taproot opens the door for Bitcoin smart contracts. We have LRay, which is making broadcasting transactions better. So right now, when you're broadcasting transactions and data on network, it's not that efficient. There's a lot of extra gossip. And LRay kind of pares that down and makes it easier and more lightweight. We also have SIG-hash no input, which is required for a Lightning upgrade called L2. So what is the Lightning Network? I think this is an important thing. A lot of people don't talk about Lightning Network. Koji, right before on the panel, did mention it. But I think this doesn't get as much attention as it should. So Lightning Network is built on top of Bitcoin. It is a protocol, so Bitcoin itself is a protocol. Lightning is a protocol as well. It's a decentralized network enabling instant private Bitcoin micropayments. So Lightning is built for paying for coffee and small transactions, or even nano transactions between machines. Transactions are cryptographically irrevocable, and everything is settled on the main Bitcoin blockchain at the end. So this is just showing, oh shit. Anybody can turn it back on? Anyways, that was this diagram. It's just showing that you open up a channel on chain between two parties, and then once you've opened up the channel, then you can transact as many times as you want, and it is privacy preserving because your transactions are only broadcast to the party that you're transacting with, versus a main chain transaction where you're broadcasting everything to everyone. So if I do a main chain transaction for Bitcoin, everybody has to receive that transaction. And then ultimately, when the channel is closed, you close it out and you make a final transaction on the Bitcoin blockchain to kind of settle. And an example I like to use for our Lightning Network is it's kind of like a bar tab. If you go to a bar and you want to have drinks, you don't go and pay every single drink. You open up a tab, you give them your card, and you drink all night, and then when you're done, you say, okay, I'm done, you sign off, and you say, I paid. I'm just skipping ahead. Okay. So Lightning is composed of 4 simple programmable primitives. Multi-signature transactions, these are kind of Bitcoin's smart contracts. Time locks, hash locks, and hash time lock contracts. So by combining these 4 simple programmable primitives, we can create a network of payment channels between individual Lightning nodes. Oh, these are my diagrams. Okay, so privacy is improved because payments are encrypted. Tor is used as a default in Lightning. So it's a very privacy-preserving tech where you can pay someone and no one can do any blockchain analysis. Also, nodes don't know where payments originated or their destinations. So C Lightning is our implementation of the Lightning Network. There's, I think, 3 main implementations, and now there's a new one from Japan. But C Lightning is ours, Blockstream's contribution. So it's written in C, that's why C Lightning. And the contributors include Dr. Christian Decker, Rusty Russell, and Lisa Neiget. But the code is on GitHub. Anyone can contribute. And this is compatible with all the other Lightning implementations. So our main focus for C Lightning is performance, extensibility through plugins, and being lightweight so it can run on really lightweight devices like Raspberry Pis. And it's daemonized, which means processes are privilege separated. So what is the future with Lightning? I think it's still very early for Lightning. If you're an advanced user or you like to hack around, it's great right now, but it's still not ready for primetime use. There are some light wallets out there, Lightning wallets for mobile phones, but they are still more or less custodial. And what we need to do is make the tech work better and more seamlessly. So these are some of the things that we think will be happening with Lightning. We'll have automatic channel balancing for end users. We'll automatically select between on-chain and Lightning payments. So you just decide if I want to send 1 Bitcoin, your wallet will decide, okay, this is just going to go on the main chain. If I'm sending $1 for a payment, it'll go over Lightning. But a lot of the complexity will be hidden from users in the long run. Also, optional channel openings with change output. So you could do an on-chain transaction, and usually for Bitcoin, there's a change output. You could use that change output to open a new Lightning channel. But a lot of this stuff will just become seamlessly integrated in the back end. Also, you can swap Bitcoin out of a Lightning channel to an on-chain payment. But there's a lot of advances coming in this area. We also have the possibility to have a Lightning network on the Liquid network. So Liquid is a Bitcoin sidechain. And if you issue a tokenized asset on Liquid and there's enough liquidity, so a lot of people hold this token, you can actually create a Lightning network out of all those token holders. So an example could be a stable coin issued in Liquid. You can have a Lightning network, which is free instant transactions. So in the future, I think all mobile wallets will become Lightning network wallets. So Lightning is also a way for scaling. It is a scaling technology in a sense. So Bitcoin is about 7 transactions a second. Ethereum Classic is about 20, and Litecoin 56. And then I think PayPal boasts 193. Centralized payment providers like Alipay or WeChat, I think they're at 80,000, 100,000. And I've also seen some blockchain projects around. They're boasting things like we're next gen, 300,000 transactions a second. But the thing is with Lightning, it's transactions per second per channel. So if I open a channel with you, we can actually achieve 500 transactions per second, theoretically. And it varies with hardware. So we've done a few tests. Like average hardware is about 250, but high-end hardware can get up to 500. And what that means is we can achieve really crazy transactions per second. So right now on the Lightning network, we have 39,000 channels. So you multiply that out, and you've got about 19 million transactions a second. That's the equivalent of a 3 terabyte on-chain block. So blockchains don't scale, but off-chain scaling tech like Lightning can actually achieve really crazy transactions per second and throughput. But I think it's also a bit dishonest when people are talking about transactions a second. So if you're here this morning listening to Nuriel saying Bitcoin's only 5 transactions a second, that's really dishonest. You have to actually look at all the tech that's available, like the Lightning network. And unfortunately, Arthur didn't talk about that, so I'll talk about it now. But hinging on a transaction per second metric is also bad because Bitcoin is not a payments rail. It is a medium of wealth transfer, and it's a store of value. If you actually multiply out, let's say, 7 transactions a second, you can actually achieve about 400,000 transactions a second on-chain for Bitcoin right now. And if you're actually moving large chunks of Bitcoin, like say $200 million, $300 million, you pay $5 and you can move that 400,000 times a day. That's pretty good. Moving Bitcoin is kind of like moving gold. It's going to be expensive in some regard because you do have limited scarce space in the blockchain, and there will be fees. So right now, with Lightning, you can see that we've exceeded, decentralized systems have exceeded centralized systems. So even Alipay, Visa, or anything like that, we can blow them out of the water with Lightning. So a bit about the evolution of money. So Bitcoin primarily is a store of value. It's a medium of wealth transfer. Money usually evolves in these three steps. So you go from store of value to MOE to unit of account. But for Bitcoin, it can actually evolve along all 3 axes at the same time. So first of all, Bitcoin is valuable. It's expensive. So that's why you can store value. As long as you're not looking at volatility over a few weeks or months, if you bought Bitcoin 2 years ago, you're up, I don't know, 4x or more right now. But it slowly evolves. But medium of exchange, we can have that with Lightning, with layer 2 solutions like Lightning. And it's also a unit of account. So for the Lightning Network, everything is denominated in Satoshis. People are tipping each other in sats, and they're counting in sats for paying or for drawing on Satoshi's place or anything like that. So Bitcoin is unique. It's digital money, and it can evolve on all three axes simultaneously. And we also can have a circular economy with Lightning. So circular economy is when people start to earn and spend. With on-chain transactions, you have a lot of friction. You have to, let's say you want to spend Bitcoin. You have to first acquire Bitcoin. And most people would do that through buying Bitcoin on an exchange. You're paying a bank wire fee to send your money to the bank. You're paying a transaction fee to buy, a withdrawal fee, and an on-chain fee when you take it. But with Lightning, you can actually receive payments. You don't have to have Bitcoin to receive payment in Lightning. And it's frictionless. So the fees are negligible, and it's instantaneous. So what that means is down the road, an employer, let's say Travel by Bit, they can pay their employees in Bitcoin and over Lightning, and then those guys might go and buy a hat from a hat store or buy a coffee. And the employer at the hat store might pay their employees in Bitcoin over Lightning as well. And that kind of jumpstarts this whole circular economy where people are earning and spending Bitcoin. So in closing, I like to say the Lightning Network will be how most people use Bitcoin in the future. On-chain transactions are always going to be there. Even when you close a Lightning channel, you probably need to close it out on-chain and touch the main chain. But down the road, as we bring on more people in developing countries, they'll probably just set up a Lightning wallet and start transacting Bitcoin over Lightning. All right, that's my talk. Thank you very much.
Once again, thank you, Samson, for this wonderful presentation. 我们再一次谢谢 Samson 先生。